Hello, everybody. Welcome to a new episode of the Dissenter. I'm your host, Ricardo Lopes, and today I'm joined by Dr. John Brooke. He is Arts and Sciences Distinguished Professor of History, Professor of Anthropology, and Director of the Ohio State University Center for Historical Research. He is also the co-chair of the 2011-2012 program Disease, Health and Environment in Global History. In 2007-2008, he served as the president of the Society of Historians of the Early American Republic. His teaching areas include early American history and environmental history. His most recent book, Climate Change and the Course of Global History, A Rough Journey, published in 2014, examines the long material and natural history of the human condition, and we're going to focus our conversation on this book today and on environmental history more generally. So, Dr. Brooke, thank you a lot for taking the time to be on the show.
Happy to be with you, Ricardo. Yeah.
Okay, great. It's my pleasure. Okay, so let me ask you first, because I guess that most people are not familiarized with this area of environmental history. So could you tell us first what it is about and perhaps the sorts of issues or objects of study that it is interested in, let's say?
Well, it's a very big area, a big zone, and there's actually divisions within it. People are fighting with each other a little bit about what it should be about. But very broadly speaking, it regards the interaction of humanity and nature over time, and the way humans have influenced natural systems, and the way natural systems have influenced humans. Now, having said that, there are many different opinions, and much of environmental history comes out of traditions of American historical writing. It has its roots by American historians back in the 1970s. And what's happened recently is a division between people who have focused on the material circumstances and those who are very caught up in what we call the cultural turn of history in general. So there's really the majority of practitioners in environmental history are of the cultural persuasion, and then there are a re-emerging group. I would say it was the original idea was the material condition, disease, natural environments, bioregions, and agriculture. And there's a group of us who are returning to that older focus that then makes us be able to connect to what archaeologists do. So in other words, archaeologists for 50, 60, 70 years have been very concerned, ever since V. Gordon Childe and the great revolutions in archaeology, have been very interested in the relationship between natural context and human societies. And so the material environmental historians are very much connected to what they do. So that's a longer version than you might have wanted.
No, there's no problem about it. So, okay, so it is mostly interested in how climate and perhaps climate conditions on Earth might have affected the environments where human history really occurred. So it is not only focused on human history with a capital H, as traditionally called, but also on human prehistory, right? And perhaps what would biologists call our evolutionary history, correct?
Again, this is, I'm being careful because the environmental historians, as they see themselves, don't always agree that we should look at prehistory. I am a group of a number of us who say we have to think about the big picture and we have to think about climate science. So there's a subset of environmental history that's climate history in the long term, and we connect into the whole stretch of prehistory in a continuous story, which is what I try to write in my book.
So these environmental conditions that you are interested in, and perhaps the climate history of Earth and how it affected our evolution, it also perhaps served to explain, at least in part, how our genes, our Homo genes evolved, and perhaps how we branched from other advanced primates, and also how we evolved, right?
Well, yeah. So here's where historians really get adventurous and reach back into evolutionary time. And the paleoanthropologists have been working for years and years, decades, on explaining how humanity evolved over 10 million years, say. And the evidence, the strongest evidence we have, we really can't get inside there. We don't know what their culture was, but we can talk about the context in which they evolved. And broadly speaking, there are arguments about how natural environments shape the conditions in which there are surges of change, as evidenced in the fossil record, that suggest that the pulses of human emergence from higher primates to modern Homo sapiens, which would have occurred by, we have been around as a collective species for about 200,000 years. And so how do you get from 10 million years ago to 200,000 years ago? And so the great debate is, to what degree did environmental changes, major global environmental changes, affect that process? And that would be a process of on the one hand, we have to think about the whole Earth as when we talk about the Earth as an Earth system and it's evolving, it has a history, it moves through time, and in the last 50,000 years, we've been going slowly from an extremely warm greenhouse condition to a relatively cool icehouse condition in which you can have ice ages. So the last 2 million years, we've had a series of ice ages. We're just riding on top of one warm spell, and we are now creating an even warmer spell by our own action in the last 200 years. But over the last 50 million years of evolution, the backdrop to plant and animal and human evolution is a progressively colder planet on a cycle that is roughly 200 million years. So the cycle goes back for about 3 cycles until we get back to paleo time and the paleoproterozoic and single cell organisms 600 million years ago. So if we think in these time frames, which are very difficult to do without pictures, and even so very difficult to think about the time frames, we are the product. We collectively, as the planet Earth and life on the planet Earth, we are part of the life on the planet Earth. There is no planet B. They may go looking for another planet, but guess what? I'm committed to this one, and we need to understand its history and where we sit within that history. So that's all a prelude to saying that, yes, that as we get into the final stages of the Cenozoic cooling, we get shifts geological shifts that line up with pulses of change in species in Eastern Africa. And that's where the action happens. So big changes in sea currents and the advance of glaciation in the Antarctic and the start of glaciation in the Arctic, all of which are context in which we get these events, big, huge events that operate in East Africa that create a drying and shifting and mosaic-y climate that modern humans emerge, or humanity emerges out of. The stresses of those environmental conditions operating over long periods of time.
Right. Okay, so at a certain point there you referred to culture and to human culture. So apart from the ways by which perhaps environmental conditions influenced our strictly biological evolution, perhaps you also put some emphasis on culture as sort of a set of tools that we developed that also allowed for us to deal also with these environmental and climate fluctuations, right?
Well, what I've just recently, since I finished the book, I've come to understand there's a whole field in evolutionary, this fairly recent field in evolutionary studies called niche construction, evolutionary niches, and there's also all sorts of new. I mean, not so new. We've been working on this for years, but animals have intelligence. So we have to combine the fact that animals almost have cultures with plants, and the entire all of biotic species have spaces in ecologies that are niches, and they influence those niches. So really, our elaboration to build this incredible communication system we were talking across, we're involved in this incredible evolutionary process right this second because of this incredible technology that was not available 10 years ago, except in people's imaginations. But the point is that we have achieved an amazing amount in the last 200 years, the last 2 million years, but it's really building on animal intelligence and the whole process by which plants and animals are operating inside of niches. We spaces almost culturally created spaces that allow them to protect themselves in an environmental context. Now, what we've done is to elaborate that, and so human culture becomes more and more and more effective, and there are great jumps in that effectiveness that occur, and we've labeled them. For decades, we've labeled them the lower Paleolithic, the middle Paleolithic, the upper Paleolithic, the Neolithic. These are the classic archaeological terms, and we are in the electronic age. But in between, there was the Bronze Age and the Iron Age are real. They really matter. They are huge. They capture gigantic organizing features of human society that do allow us to buffer our space, create protections against the forces of nature. We've just gotten really, really good at it in the last couple hundred years.
Mm-hmm. So when we get to agriculture, what are perhaps some of the main environmental aspects that is important for us to pay attention to in order to understand perhaps what were the environmental conditions that led that facilitated perhaps the acquisition and development of agriculture, and perhaps the ones that really allowed for the evolution or the existence of certain types of plant species that were the ones that we took advantage of and domesticated and even changed over time, and that really led to the ones that now are at the basis of our agricultural systems.
Well, one way to look at this is to realize that, yes, 200,000 years ago, we reached, an approximation of our modern intelligence. There's been one warm-up in the Pleistocene since then, and then there's our warm-up. And so the first one, they kind of enjoyed that, but they didn't see any need to develop agriculture. The populations weren't dense enough. But after the end of the Pleistocene and the Younger Dryas and the very cold epochs at the end of the Pleistocene, we have this incredibly rapid warming that happens.
By the way, sorry to interrupt you there, but you're talking about the Pleistocene. Could you please just give a time frame there, because most people perhaps
broadly the Pleistocene is roughly 1.5 million years ago to about 10,000 years ago. And then there is literally, after all this incredible, we just can't imagine how the variation in climate just was very wild. And then we suddenly warm up in literally, 200 years, 300 years. It happens incredibly fast. The line goes straight up. And what we get are two things. We get three things. It's warmer. It's wetter, because all that water that's been locked up in the glaciers is now flowing into the oceans and is part of the global hydrological system, the water system. And then there's more CO2 in the air. The CO2 rises from about 180 parts per million to 280 parts per million. And that may have been a very important part of the process. the plants that we really, the C3 plants, the plants that like wheat and barley have been had about 50% of the yield before in the ice age, and 25% less germination. So they suddenly become much more productive, and people are settling into very productive environments. They're finding spaces that are near swamps and near the ocean and near high grasslands where the wheat is growing. And so they're finding very productive, ecologically productive spaces, and actually settling down and exploiting, instead of chasing the herds across the ice age steppe, they're now settling into these very rich places, and they're becoming increasingly dependent on very, very productive species like wheat or rice. So wheat and rice are the first to be domesticated in Southwest Asia, in basically Levant, and the other in China, and out of those will come, these great agricultural systems, but they requires, a good 1,000 years of kind of co-interaction between plant and people to sort of settle into the codependency. The most successful, probably the plants are more successful than we are, because they get some little schmuck, meaning the human person, to run around and propagate their species for them for nothing, and they're and we have to learn how to do all this work. So one of the dimensions of the Neolithic is increasingly intense work regime focused on managing fields that is completely alien to that hundreds of thousands of years of migratory hunter-gatherer condition. And this, by evolutionary time, this is happening instantaneously.
Mm-hmm. Right, from an evolutionary perspective, from the time frame that we usually look at when we deal with evolution, right?
Exactly. Yeah, right. Yeah. Mm-hmm. Of course, in historical time, it's a huge amount of time. It took 1,000 years. Well, in evolutionary geological time, that's nothing.
Mm-hmm. Right. Okay, so when we talk about agriculture in human history, people usually say, oh, we've adopted agriculture some 10 to 12,000 years ago, and that's it. They talk about it as if it was sort of a unitary event or a single event, that we simply adopted it and it started spreading, and that was it. But in fact, in early agricultural societies, many of them adopted agriculture and they established the societies, but then they crashed and then they adopted it in other places, and so on and so forth. So it was really it really went through a process, perhaps, of societies adopting agriculture and then losing it and then adopting it again due to perhaps also environmental fluctuations that influenced how effective the process was and things like that, right?
Well, I'm not so sure that once, I wouldn't say that agriculture once adopted was abandoned. There are very few cases. I mean, there are cases of under extreme stress, people reverting to herding. But probably never abandoning the whole concept of a domesticated plant and animal species and their dependency. Probably things got stressful, no question. There is a phase at the earliest, there is a whiplash effect in the earliest end of the Pleistocene, where the climate warms way up and people settle down, and then the climate gets cold again. It's called the Younger Dryas, and they have to revert to hunter-gathering. But after the pretty arduous process of transition, you get the codependencies become so strong, the populations become so dependent, and they lose the knowledge. They lose the knowledge that the hunter-gatherer peoples of the Pleistocene, of the ancient past, knew incredible amounts of things about the natural world that more or less are going to be forgotten because they've become so dependent on these new crops. So, but on the other hand, there's no question that ancient societies rose and suffered crises. Let's put it that way. I won't say rose and fell, but they suffered crises. They had moments of high stress. And the question, one of the big questions that's out there among archaeologists and increasingly historians is, how much was that due to overpopulation and resource stress? And how much was that just due to the natural history, meaning climate change? There are, and this is a difficult topic to describe, but without a lot of pictures. But the reality is that there have been the last 10,000 years have been fairly even relative to the Ice Age. The Ice Age was incredibly choppy, and then in terms of temperature, but then the Holocene, the last 10,000 years, looks very smooth. But then you realize that there are some periodic stress periods, and it turns out that across the board, around the world, those small moments of 300 or 400 years of what we call mini ice ages had global effects. And so so much of the debate we're going on right now is how do we get inside of those events, and how do we understand what happened in these periodic stress points in human history, human agricultural history.
Okay, so earlier you referred briefly to the fact that some people try to focus more, perhaps, on explanations that have to do with people over-exploiting the environment or their resources, and they put forth that as explanations perhaps to some societies crashing and things like that. But what is really the relevance of that in our history, and particularly since agriculture took off? I mean, does that play a really important role, or perhaps the environment and environment fluctuations is more important?
Well, this is the debate. This is the debate. I personally think that all things being equal, ancient and medieval societies did okay. They suffered. They lived short lives. They were constantly being abraded by disease. They really had difficulty raising their populations. Every now and then they seem to do better. And the problem is, every time they do worse, in the past, it's always been, and we should back up a bit. In other words, what are the purposes of environmental history? And the first wave of environmental history, a lot of people saw these crashes and said, these are metaphors for our current condition. That these ancient peoples declined in the same way that we are faced with crises here in the 20th or 21st century. The most famous of these is Clive Ponting wrote very influential in early environmental history. Donald Hughes on Greek history. Jared Diamond on a book called Collapse. And they all basically say, beware, people of the earth today. Look at what has happened, these many centuries ago. And my position is the conditions, these many centuries ago, are completely different. We live in a new world. We are talking across the Atlantic in this instant because of the scientific revolution. We have totally transformed our circumstances. We both hope to live to our 80s and 90s. All right. They hope to live into their 30s and 40s. And so their societies individual lives were very short. The societies actually lasted for huge amounts of time. It's been about, really, I don't think the Industrial Revolution really began seriously until the 1870s. So that's how long ago? That's 150 years ago. That's 150 years. And we're thinking about the crisis that we have caused. These societies lasted for hundreds and hundreds of years. The people in them died. The conditions were very hard, but they didn't crash because they were overpopulated. They declined because of large-scale natural system forces that which much of the body of my book is focused on. I didn't actually think I was going to come to this conclusion, but this is where I got. I mean, I really started with a classical Malthusian idea. I said, wait a minute, I'm getting everybody saying something different. The evidence is going a different way, and the climate fluctuations, the climate shifts line up with the great archaeologically described declines of civilization. So, one of them, broadly speaking, we've always known about a kind of a crisis in the fourth millennium, another in BC, another one around 1200 BC, which is the transition from the Bronze Age to the Iron Age. Then another one, which is broadly what we call this term that people don't like, but the Dark Ages, 500 AD to about 700 AD, and then the Little Ice Age that variously begins at, there are various definitions of what the Little Ice Age was, but we'll say it happened between about 1500 and about 1800 or 1700. And those events clearly line up with major reversals in human condition. And the one we know a lot about right now is the Little Ice Age that occurred at the end of the Middle Ages. And we know a huge amount about that. And what we don't know as much about are these ancient events of the fourth millennium, of the 1200 BC period. We're kind of scratching at the surface of what's going on in the so-called, it's now being called the late antique Little Ice Age, which is roughly 500 or so to about 900 BC, 80, sorry. Yeah. Mm-hmm. So there is this, was it overpopulation, or was it that the natural systems no longer could support on a global basis? And that's one of the things that's really striking is that historians have started to look at circumstances. Victor Lieberman wrote a book called, massive 2-volume book about all of Eurasia called Strange Parallels. And what the strange parallels were that societies all over the Eurasian continent, from England, not exactly on the Eurasian continent, but essentially Eurasia, all the way to China, societies are rising and falling on the same periodicity. And he realized this is really the medieval warm period and the Little Ice Age. And these are broadly global patterns that are shaping circumstances. And then the question is, how do people respond? How did those people respond to the pressures that are put on them?
So we're talking about climate and climate change and perhaps how it affected agricultural societies, and we're focusing here perhaps in how it affected agricultural production and things like that. But there are other aspects, like, for example, epidemics and the spread of disease, and perhaps during history there were certain periods where the climate conditions really favored the development of certain parasites and pests that spread disease throughout several different populations, and that also was a factor that contributed to certain societies collapsing. Correct.
Well, I mean, this is another enormous debate that's evolved over the last 10 years, I would say, which is particularly regarding the plague, the bubonic plague. This is kind of the center point. There clearly are many other disease vectors that are equally important, one of which is, the rise of malaria. I mean, imagine, I'll just for a second, the end of the ice ages, and the water rises, and all sorts of cold, hard ground suddenly gets swampy, and mosquitoes start to fill in, and we start to get malaria that had never existed before. So and people are living in those environments and getting malaria where they would never. Malaria had to emerge and had to spread, and the end of the Pleistocene, the end of the ice ages, and the wettening, or the warmer and wetter world produced a broad context for disease. I'm going to turn this light keeps flickering, so I'm just going to turn it off. Then we have the question of ultimately there's a question of smallpox, which is really, I would not say there's any climate connection, but really the bubonic plague is the big one. I mean, you have to think about, if we just think about Eurasia, not think about the Americas yet, but we look about Eurasia, bubonic plague is the enormous story, and in the last 15 years, the hard genetic data is coming out of bones from cemeteries in the Middle Ages that is now pretty conclusively demonstrated that this was Yersinia pestis, and it can be part of a genetic tree that can be connected back for now. Well, that's the point. Now we understand that the plague is of ancient origins. We're now finding, and new articles are coming out every 6 months, changing the story slightly, but we're now back into the late Neolithic and early Bronze Age for the origins of the plague. So it turns out that there probably were not only the Black Death in the 14th century, 1350 plus or minus. Where did that come from? Did changes in moisture in Central Asia contribute to the rise of the initial burst of the plague somewhere in Central Asia that set it in motion to the west and into the east, into China? Then we have the issue of the Justinian plague, which has also been genotyped to Yersinia pestis, and can be modeled into a tree of genetic history that connects it forward to the Black Death. And that also lines up with a shift from warmer to colder conditions. Did those colder conditions create wetter conditions in Central Asia? Seems to be the pattern. Is there, in fact, twice this pattern happened where things got globally colder, Central Asia got a little wetter, and there was a burst of plague that burst out of its natural bounds? Same time, clearly, there's also issues of warfare. Did the Mongols help to spread plague in the late Middle Ages? Did various we'll call them the Huns, literally, moving around and conquering sections of Central Asia? Did they disrupt ecologies and peoples to set off plague epidemics? I don't think the soldiers did it. I think the refugees from valley. Imagine Mongols or Huns coming into a nice agricultural valley and everybody running for their lives up into the mountains where the plague is hosted. The plague hosts live, meaning the rodents. I think that's where how the plagues really got going. But meanwhile, there's an even more ancient story, which is the root of the plague goes back to 4000 BC. And we've now been able to, if you do the mathematics of when, as they do with all genetics, when is the most recent common ancestor? Well, it goes back to about 4000 BC. Then the hard bones are now emerging out of collections all over Europe and Russia that show us that there are about 15 samples scattered across the early Bronze Age into the early Iron Age. Earlier versions of the plague turning into the bubonic plague, and there is the big question right now that's just been opened up in the last year, I would say, is: was there a plague of Black Death scale in the late Neolithic in Europe? Question mark, question mark, question mark. There is a decline in the late Neolithic from about 3500 BC to about 2800 BC has a decline in, there's clearly a large population or a population of X size, and then the sites drop. The number of sites drop, and it looks like the population drops for 500 years. What caused that? Now people are literally saying, they're finding burials with plague in them and beginning to say, I think we can make an argument that plague entered into Europe through some dynamic and contributed to a mass death context. which, if I could just go on for one more second, reminds me as an American historian of what happened in North America when Europeans came into North America after 1492 and brought with them not the plague, but smallpox, chickenpox, mumps, measles, and this spread under stressful conditions into the Native American populations, and you have a huge die-off, a massive, 80% die-off of Native peoples of the Americas under the impact of diseases. So, yeah, it's really, disease may be more important as a crisis mortality driver than climate. Climate might be a contributing trigger factor for some of those epidemics.
Mm-hmm. And you refer to the Mongols and to the Huns, and that would be spread of disease through war and conquering, right? But I
think not necessarily that they carried the plague from place to place, but their military operations in Central Asia might have disrupted societies to get the plague going, and then it's spreading in the trade routes and suddenly arriving in populations, dense populations in China and India and Europe, in Mediterranean, that massive loss of life. Yeah. So it's not necessarily precisely the armies that are carrying the plague, but it's they're the disruptors at a critical points.
Mm-hmm. Yes, and another way in which we can establish a relationship between climate history and climate change and perhaps wars is the fact that perhaps in certain points during our history wars developed precisely because people were led to violent struggle over resources, right?
Well, that is actually probably true, and they're beginning. There's an evolving analysis about ancient warfare, particularly essentially tribal warfare. And they're finding this in that there is a good argument to be made and or a hypothesis to be developed, to be questioned and wrestled with, that they kept their eyes on the climate conditions, and when they feared crop failure, the armed parties might launch out to take stuff from other people. So we literally, ancient peoples keeping their eyes on their conditions, and in anticipation of, I think things are going bad. We need to raid them to get their resources because we're about to lose our resources, or we're already in stress. But there is clearly the whiplash effect, one way or another. There's a huge argument about which way it works. Is it that people anticipate, or do they recover from one event where another people are suffering? And so we're really just beginning to be able to sort this stuff out because the evidence is getting more and more precise. The evidence from the 25, 30 years ago, we would have no idea about the climate. You had simply zero idea about what the climate fluctuations were. But now there's so many holes drilled in the ground. It's evidence that comes from holes drilled in ice, in trees, in soils, in lakes, that we're getting increasingly dense, non-documentary history from the Earth archives. The stratigraphy of the Earth is telling its stories, and the geologists have known this. The archaeologists have always known this. Historians are slowly catching on that we can get this more and more refined. People are fighting for the most high-resolution data. Can we get it on an annual basis? Can we get down to seasons? Oh my gosh, this is getting a little crazy. But there are very aggressive efforts to get more and more detail over longer periods of time to be able to make more and more precise arguments.
Right, and that's all very interesting. So just before we move on to the next topic that has to do with the Industrial Revolution, which you also talk about in your book, let me just ask you about this because it just came to my mind. I don't know if you read it or not, but recently there was a study that came out. I can't remember the authors, but they were referring basically to the effects that Europeans arriving in the Americas and killing through the spread of their diseases, let's say the diseases that natives were not immune against, that it killed around 55 million people, that corresponded to roughly 1/10 of the human global population back then, and they associate that with, I think, a decrease in global temperatures, because supposedly those 55 million people dying because they discontinued, at least in the short term, their agricultural activities and things like that. That might have had an influence on the global temperatures, let's say. So, would you have something to comment about that? Since earlier we were referring to overpopulation and things like that. So.
Well, what you're referring to is the most recent. I mean, the most recent article to explore the question of the dynamic relationship between agricultural peoples and the atmosphere. And this was first proposed, I must admit, and I've been teaching this for 25 years, and I used to talk to my undergraduates about literally 20 years ago. I said, it's kind of funny that something's happening here. It's kind of weird. Why is maybe humans are actually affecting the climate in some way? And then in 2003, I think, William Rudiman, December of 2003, William Rudiman, Rudiman, of the University of Virginia, published the first article that argued two things. One, ancient early agriculture, and he later said, okay, expansion of early agriculture, put enough, particularly methane, up from rice paddies and from cattle expansion of cattle herds and their burping, but also clearing land, and the question of how much does the clearing of land, the burning of land, and the inefficient uses of the land produce emissions that might subtly change the course of atmospheric history. So he basically argued that and this has been under hot debate for 15 years, that we would be in the beginnings of an ice age, except for just the incremental whiffs of greenhouse gases coming up from early agriculture, Bronze Age and Iron Age and medieval ancient agriculture that just stabilized the earth just a smidgen. Then, point two of his argument back there, which is what another focus of great debate, is the point that you just made about mass death in the Americas, mass death during epidemics, producing a reaction, which is when people die, they stop using the land, and the land grows up again. And when a forest grows, it uses water and minerals and CO2. So it draws the CO2 out of the atmosphere. So there is a case to be made that the Black Death, particularly in China, might have had a slight effect on the atmosphere based on the ice core data from Antarctica. And then there are some severe drops in CO2 and methane in the late 16th, early 17th century, and that seems to line up with mass death in the Americas, particularly in what are called the neotropics, which would be from south of Mexico all the way down into the Amazon, where huge tracts of land would have been open, and now people die and they all grow into jungle, and that just pulls down massive amounts of CO2. That's the hypothesis. Highly debated. Everybody's fighting about, what are the circumstances in which it would have to be true to make this a viable case. So it's not proven. It's a great thing to talk about in class because it gets students they understand the concepts a lot better. But, my personal opinion is Little Ice Age was already happening mass death in the Americas may have pushed it a little further. But there are solar minima, there are volcanic eruptions that are already cooling the planetary system, and so we're in a situation where we want to be careful and not go too crazy with this argument. It's one that's hit. It was in the Guardian. It was all over. I've already interviewed somebody already about this. Somebody that interviewed me about this issue because it's so striking. But it is very interesting. We don't know what in fact actually happened.
Mm-hmm. Okay, so let's now talk about the Industrial Revolution. And I mean, it was a major event in our history, and now it's affecting also the global climate through man-made climate change and things like that. And we're going to talk about the Anthropocene later in the interview. But just before we get into that, I mean, what is the relationship here between the environment and environmental conditions and the development of the Industrial Revolution, and particularly in the northern European states? Is there any relationship there?
Well, this was, again, something that kind of almost the grade school approach would be, let's see, it was actually getting colder and they start burning coal, and it was getting colder and they need more sheep to have more clothes, and they need to have more they need to find other places to grow fiber because they need more clothes. So that simple 10-year-old interpretation, which is, literally a kid could come up with that interpretation. People are beginning to take that seriously. That the conditions of the Little Ice Age made people put on their hats and get warmer. So, I'm being only slightly facetious about this. And it looks like a similar kind of situation happened millennia before that in previous downturns. The transition from the Bronze Age to the Iron Age is another technological revolution, and the conditions during which that happened, breakup of empires, look very similar to the Little Ice Age. So you can argue that these great pulses of climate reversal stress produce cultural responses, and so this will be this is really there's a number of us who are starting to say this is pretty obvious that the stresses of the Little Ice Age produces responses, and people start looking for creative ways to deal with the cold. And very simply, that means burning coal if you have it, burning peat if you don't have coal, and finding more fiber to make more clothes. And those are the essential, if you put those came together in England in the 17th century, and they had a wood crisis already from the middle of the 16th century, the 1500s, and they started burning coal. I mean, you may have heard of London as as this horrific, smoggy city from the late Middle Ages. Well, that's because they were burning coal that they brought down from northeast of England to burn in the city because the wood was all gone. Anything they had to save for very specific purposes. Yes, I do think, and I will wager serious money on the argument that there is a causal relationship between the stresses of the Little Ice Age and the kind of the combination of developments that will lead us to the proto-industrial revolution unfolding in England by the 18th century, in Northwest Europe generally by the 18th century. And so, yeah, the causal relationship. So on the one hand, climate may have caused the fossil fuel revolution that then causes the Anthropocene. In other words, you start to inject all this coal smoke into the air, and by 1896, people are saying, I think we might be changing the environment. People are already thinking about the possibility of an Anthropocene by the 1890s.
Mm-hmm. Okay, so let me just ask you now about this, because, I mean, this is perhaps somewhat of a contentious topic, but about the certain certain societal and moral developments that we got after the Industrial Revolution, and a big one of them was the abolishment of slavery. Because, I mean, with the introduction of the Industrial Revolution, eventually we got into a place where really we were, for the first time in history, able to effectively replace human power, or the human power that came from our muscles, let's say, with machinery and really new technology that perhaps rendered it even better and more efficient for the industrialists to have their production and things like that. So, I mean, when we talk about history, there are people that prefer to focus on the history of ideas or the history of values, but in your book you refer to perhaps the influence that the Industrial Revolution, through this process that I've just described, might have had on the abolishment of slavery, because perhaps it was no longer an efficient process to have people doing what machines would do better. Right.
Well, I right now I have two hats. I wear two hats. One of my hats is global environment. The other hat is American political history. I just finished a book about that bears directly on slavery and the origins of the American Civil War. So I can say two things. On the end of slavery, on the ground, as people are the vast majority of people talk about it, they don't comprehend an energy revolution. They don't see, but there's no arguments being made at the time, we should end slavery because there are no dominant arguments. People actually do say that. There are very few people. So what is striking is that there is a book published in 1859 or 60, and it's actually reviewed in William Lloyd Garrison's Liberator, which is the big anti-slavery newspaper in the United States, which basically says what you just said. It's inefficient to have slavery. I don't think that was the driving force, but I think a few people did the numbers and actually said, and if you do the numbers, you find that, if you make some calculation for BTUs of work energy by coal versus BTU British thermal units of work energy from slaves, it starts off in the 1800 where coal is irrelevant. By the 1840s, coal is in fact, by the 1850s, coal is way beyond the total British thermal units. People didn't think of it in those terms. We can look back and say that was what the system was. On the other hand, you can't do this. Now we can do this maybe with automation, but the physical, the things that slaves were being used for exploited the human dexterity. And so human dexterity in picking cotton, and until picking could be mechanized, which is only in the 1950s and 60s that some form of labor system was that involved human beings was important. And as far as the slave owners are concerned, why not have slavery? So in the end, I do think that slavery was a moral issue and was fought over on moral and political terms. But lurking in the background, there is this reality that there is an energy. A few people recognized it, very, very few, high intellectuals, but most people were very much on the ground with, on the, if we don't kill slavery now, it will last forever, a frame of reference. That's the question of how long would I speak as an American, how long would slavery lasted in America? It ended here in 1863, 1865, which is only 140 years ago. How long would it have lasted without the Civil War? So again, an interesting topic, and one that I kind of lay out throw a little tidbit out about. I don't think it was at the time the driving idea. Yeah.
Oh,
Not that, you know, what would have happened? The real question what would have been the circumstances by 1920 if there had been no Civil War and slavery had persisted for another 50 years, and then you had the industrial complex of the 1920s and still a slave labor force. Maybe you could have adapted the slave labor force to work in the industrial circumstances. Maybe you just simply needed to have it all out. You need to destroy it by force. Anyway,
So perhaps if we didn't develop this sort of moral approach that really was for the abolishment of slavery, perhaps with time people simply would have moved slaves from certain types of work to other kinds of occupations, perhaps.
And actually, that's what they were increasingly aware of at the time. They said, well, there's no logic why slavery can't be used. It's already, the Southerners, slaveholders were already beginning to use slaves in industrial contexts and in mining. And so there is no logical reason. If we just diverge, there's a big debate unfolded in American history, which basically the old traditional model was the slaveholding South was an ancient, backward-looking feudal society, which the modern North had to destroy to, blah, blah, blah. No, there were two modernities. One was a free labor modernity. One was a slave labor modernity. You could perfectly well have a modern society based on slave labor. And a lot of corporations wouldn't mind that right now. Actually, what they'd rather have is no people at all. Just automate everything and just forget everybody. And then, of course, they have no market. But anyway, sorry to ramble on here, but I think we need to think of it as slavery could easily have persisted and dominated. So I'll stop there.
Earlier, just to end the question here, earlier you referred to the fact that perhaps there were not many people really paying attention to the fact that machines perhaps were more efficient in doing certain types of work and things like that, and that was really not underlying what has happened in terms of moral evolution or moral development, let's say, but couldn't it be the case that perhaps at least partially, simply through people living in new conditions with access to these new types of technology, that if, for example, certain industries or companies were to adopt these kinds of technologies, they would grow, and the ones that were more dependent on human muscle power, let's say, they would lag behind, and so not at a conscious level, but unconsciously and through over time, people would.
I will say something that's rather dangerous, but think of how cell phones are constructed in Chinese factories right now. Mm-hmm. It's virtually slave labor. I mean, in other words, there are people living in dormitories, working 12-hour days on little tiny manipulations and that could, and maybe they couldn't be done by slave labor, but we have to think about, the forms of coerced labor that are that are operating behind this world that produces these wonderful little machines that make us think that we're living in a modern world. Well, actually, behind it, there's a lot of very badly paid labor, which is perhaps another form of slavery. So that's where I kind of jump off the environmental, economic, technological ship and dive into a moral understanding of how things have. Decisions had to be made, and they were really independent of. But anyway, there's always the possibilities, there might have been, which would be fun to argue about, though.
Right. And that's true. And we also have to take into account what you're saying about Chinese factories and things like that, which is very, very unfortunate. So, and anyway, with the introduction of industry and the Industrial Revolution, we got into this phase in terms of the history of our global climate that we now call the Anthropocene. So, what are perhaps the main differences here, and why do we consider these a new environmental era or period? I'm not sure about the nomenclature there, but
yeah, right. Well, there is another debate that's been underway for 3 or 4 or 5 years. The term Anthropocene was coined by Mr. Cousin about 35 years ago, kind of out of the blue. People had been kind of trying to find some term, and he suddenly snapped. It's not the Holocene, it's the Anthropocene. It's humanity driving a geological epoch. And so on the one hand, some geologists have there's actually a working group of the stratigraphic society that is trying to define a hard marker that would be visible in the geological record hundreds of millions of years from now. And they more or less have settled on the bomb as a 1945, the first nuclear explosions as permanent markers in the geostratigraphy that would be visible in the distant future. So that's a marker of the Anthropocene. As an historian, I take a softer, more expansive understanding and say, on the one hand, we have the Industrial Revolution in its wider expansion of the use of fossil fuels. We also have the whole post-1492 global expansion of agriculture that may, in fact, we can think about, there's a kind of Jeremy Davies wrote a book in which he used the term the end of Holocene event. Sort of thinking of what processes over what centuries does the Holocene kind of grade into the Anthropocene, and part of that would literally be the occupation of vast stretches of the Americas and the transition of vast stretches of the non-first world into agricultural dependencies of the first world. And what are the if the Little Ice Age and the death of Native Americans may have produced a drawdown of CO2, can we talk about the clearing of, say, North America as just the land clearance as producing a puff of CO2? And you actually can see it in the data. You can see what I call an organic Anthropocene beginning to happen by about 1820. And by 1840s, the United States is probably a greater producer of greenhouse gases than China. China has always been the big one, with methane gases coming off of the rice paddies, kind of background human condition. But then the United States shoots up in its land use emissions, and those land use emissions remain high enough that industrial emissions from coal and then some gas and stuff, gasoline, they don't cross until 1910. Land use emissions are bigger than industrial emissions until 1910, and then industrial emissions go straight through the roof. And so what we're talking about is on one hand, we have, if you think of the line of the expansion of the fossil fuel emissions, greenhouse gases, mostly CO2, coming out of factories in Europe, the United States, Russia, China, Japan, and the northern mid-latitudes. Those, you see a rise to about, particularly North America and Europe, to about 1914. What happened then? And then a jagged line that follows the First World War, a little bit of prosperity, the Depression, the Second World War, and then after the Second World War, a straight line, massive amount of as the global system just turns to the fossil fuel revolutions. So 1945 to the 1970s, a massive expansion of fossil fuels. And then from the 1970s on, every time there's a depression, you can see a little notch in the fossil fuel emissions. You know, in 2008, there's a little in the estimates of global fossil fuel emissions. There's a little notch because the economies took a hit and the fossil fuels stopped being produced as much, being used as much, and the emissions not being produced as much. So there is a direct connection between, you know, the expansion of the modern economy and all its benefits and the pressure on the global atmospheric envelope, which is now having, you know, all these other, you know, we have, so you warm up the planet Earth, you inject CO2 into the atmosphere, which is being drawn down into the oceans. The oceans are heating and expanding, and they are acidifying. So we then destroy the habitat, we destroy the coral reefs, and this huge stretches of tropical habitat are being destroyed by acidification. Then you have this question that literally, you know, I've heard the first lecture on this, I already knew about it at that point, about 25 years ago, of the potential for a runaway warming if we get to a tipping point and suddenly the Arctic goes into a terminal meltdown. We probably have reached that point within the last 5 years of the crisis meltdown in the Arctic. The Arctic has been glaciated, began to glaciate when we became, you know, 2.5 million years ago, when we shifted, when human species began to make the transition from Australopithecine to Homo habilis, you know, the Homo sapiens, the Homo genus, not the Homo sapiens species, but the Homo genus emerges coterminous, you know, at the same time as the beginnings of the Arctic glaciation, and now it's disappearing. And if you release the methane and the CO2, which is happening already, but if you had a total release, you would quadruple, double to quadruple the CO2 in the atmosphere. We would reach, you know, so the numbers here actually matter. And when I teach this stuff, I gradually, over the last 20 years now, make it absolutely required that people memorize these damn numbers, if I might be so forceful about it. During the ice ages, 180 parts per million. During the Holocene, broadly the pre-industrial past, 280 parts per million. Okay, we have broken through 400. And when I was a little kid, we were at 315. So we've gone from 315 to pushing, we'll probably be at 415 within a couple of years. And we've done that in, you know, one lifetime. And, you know, last 50, 60 years. So it's accelerating. The pressures have been accelerating. So the question is, how do you steer the whole thing? How do you reverse this? How do we handle this circumstance that we have created? We benefit from it. You know, we have lived longer lives. We have more comfortable lives, and the poverty rate around the world has dropped significantly. The infant mortality rate. There are global benefits from what has happened. Problem is, we are now facing this enormous crisis. And we have huge stretches of southern Africa and huge stretches of the upper Great Plains at this moment covered with water because of storms that are generated by the volume of moisture in an overheated atmosphere. Exactly. Yep. Exactly what people predicted 25 years ago. They said, this is going to happen. Well, now it's happening right now. And really, they didn't really think it would happen this fast. Mm-hmm. They thought these effects would be coming in about 20 years from now, but now they're happening right now.
Mm-hmm. Right, and so looking back at our history and perhaps referring to the things that we've been talking about here today regarding environmental history, what do you think? What do we think we could extrapolate from early human societies, and perhaps what happened there when the climate conditions changed to nowadays, in terms of perhaps what might be the social consequences or even the consequences for human civilization that might derive from human-made climate change now?
Yeah. Well, the problem is that the world is so fundamentally different. I mean, at the end of the Pleistocene, the end of the ice ages, there were about 8 million people total, 7 to 8 million people. That's it. And now we're at, we're on the way to 400. We're on the way to 400 million. That's just the United States. We're on our way to, what is the number? 9 billion? I've lost track where we are.
I think that in 2050 we will reach 9 billion, I think. Yeah.
Yeah, right, 9 billion. And that number tracks exactly the pace of, if you take a chart of gross national product, of population, of CO2 emissions, they all track exactly along the same line. Little tiny fluctuations, but basically there's been a huge fundamental transformation. So generally people ask us historians, wise one, predict from the past to the future. Well, you can't do that because the situations are fundamentally different. We have to understand how different our world is now to understand that we're on our own. We can't go back to the last time something like this happened was the transition from the cold of the ice ages in 200 years to the warm of the Holocene. And that produced the agricultural revolution. It produced, fundamental environmental changes, and everything changed dramatically, for better or worse. But it was a new world that humanity adapted to very, over 1,000 years, a couple thousand years. But given that we had been hunter-gatherers for millions of years, suddenly we become agriculturalists in a couple of thousand years. Is not a big deal. So what is our problem is right now, there are so many of us. There are, almost 9 billion people. This is an insane number of people. And this may be just too many people for this planetary system to handle. And how do we manage that? Plus, we have the political problem, which is manifested in Europe and is manifested in the United States, which is hold the line against refugees. Well, the climate refugees are just starting to come. Really, in some measure, the refugees who were flooding into Europe several years ago, the ones from Asia were political and wartime refugees. The ones from Africa are climate refugees. There is a fundamental reality that over the next, it's or even the war refugees that coming from Syria and coming from Afghanistan, they're also climate refugees because there is a increasing water stress that is predicted to get much, much worse running as the earth gets warmer. The whole stretch from Pakistan all the way to Senegal is a stretch of projected to have not enough water to support its population, and not unlike there are droughts, not quite as strong, but the role of drought in Central America is also playing a role in our refugee movements. It's not the total story, but it's part of the story, smaller part of the story. But I think this is the thing that we have to come to grips with. So how do we handle that, and how do we it's a complicated process, complicated problem, and the most important thing is to develop political consensus that will allow us to begin to handle this, and there are too many kind of primordial hostilities that clearly right now are getting in the way. We have one, just a walking, breathing primordial hostility in the White House right now. If I might well be quoted on that.
So you really think that perhaps one of the big problems we will have to deal with in the future is perhaps how to deal with such huge numbers of people, that perhaps if we had fewer people and with the technology and science and other aspects of culture that we have at our disposal today, we could deal with climate change more easily?
Well, yeah. The question is, that little kicker in there. If we had fewer people, that's a very dangerous thing to say.
Right. I understand.
We can't let that slip off our tongues because people will take that a little too seriously.
Right.
So yeah, I mean, it's the political calculus of how do you get the general, almost existential problem. How do you get populations to understand that they live in some place beyond where they can see? I live in Central Ohio, and that's all that matters, et cetera. That's the standard view of the world, and really, relatively speaking, very few people can handle what it means to live on a small ball of green and blue ball, the planet Earth, with populations that are of the scale and productive pressures that are pushing up against the edges of the Earth system. I think one of the striking features is young people understand this better than older people, and the great kind of tragedy is the sense of despair the younger people have about the future, that there is no future. So what we have to do is figure out a way to make a future, and I mean, that sounds all very nice, but how do you do that? But one of them is to the optimistic side of this is renewables. In other words, how do we get through this process? We can project forward. We can talk about the experience of the histories of the last 10,000 years and say that we've been through energy transitions. Now, in the past, those energy transitions have taken a lot of time, and the most dramatic one, obviously, is the fossil fuel transition. But we're trying to do an energy transition sped up. This is what the politics of renewable energy is all about. How fast can you make it happen? Or should we say the economics of energy transition? Because what's happening here, and this is what, William McKibben just wrote a major article in the New York Review of Books that summarizes new reports that paints an optimistic note, basically saying that solar and wind as energy systems have over the last 2 or 3 years suddenly become so cheap that they are driving fossil fuels out of the utility markets. That if you have to build a plant, you're not going to build a fossil fuel plant because it's more expensive right now, and it's going to get even more expensive, and all your money is going to be locked up in this stupid energy plant. Whereas if you build a solar energy system or a wind energy system, it's cheaper, and they can put, literally, it's all about what is the contract, per, cents per kilowatt hour, and that cents per kilowatt hour has been dropping and dropping and dropping. So there is a light at the end of the tunnel. The problem is how long will it take us to get out into the sunlight, out beyond the end of the tunnel, and will that happen quickly enough? And that's where so that really is the can that happen fast enough, or will it, there will be a transition. We will be here 100 years from now. We will be doing something differently. The question is whether the events of the next century are going to be mild or traumatic. Well, let's hope for the mild, and then we can manage our way through this and not have some kind of giant, horrific thing happening. But literally, I didn't know this, but McKibben argues, has evidence that data showing that India has, within the last year, has made a huge commitment to solar, abandoning new construction of coal. It is a gigantic step, because China you can see Chinese emissions leaping off the charts in 2002 when they really went into their global industrial productive mode. And the problem has always been how to get China to back off, and then worry on when India finally starts to really, they're moving at a much slower pace. Maybe they're going to be moving at a more rapid pace, but leapfrogging over the remnants of the fossil fuel economy and straight into the renewables. And that would have a huge impact.
And we also have to consider nuclear power, right? Because at least for the moment it seems to be the source of energy that really works more efficiently and also helps reducing CO2 emissions a lot, correct?
Yeah. Well, that's way back when, 31 years ago, when we started reading a bill of James Hansen spoke in front of Congress. And I distinctly remember reading the newspaper saying, oh, my God, because we have been deeply involved in anti-nuclear demonstrations, Seabrook plant up in New Hampshire. It suddenly occurred to me, oh, maybe that would be a solution to this problem, that, the problem of nuclear waste storage is a long-term problem, but it doesn't create these short-term issues of, the climate is changing rapidly. So yes, maybe nuclear, but in Europe, particularly in France, nuclear is a reality. Nuclear is a huge part of the production of electricity. They have a militarized, hyper-efficient system. At least that's what we're told. I don't know whether they're actually keeping control of their waste, but they claim they are. But in the United States, it never was very well run to begin with. The cost overruns for the nuclear plants were massive. The management of the nuclear plants was sloppy and bad. I don't see it playing a huge role in the American. Part of the problem was that coal was cheaper. Well, now it's going to be solar and wind are going to be cheaper. There was a moment there I did hear this idea that they could build these little nuclear generators. They'd be like you use on a nuclear submarine, and you could put them in neighborhoods in hardened silos, and you would have little localized grids. And you just pull these things out and put them into a container and put them on the back of a truck and drive them away when they were dying. But I haven't heard anything about that. That has an attraction, but other than the fact that you have a nuclear bomb down at the corner, somewhere nearby, you're going to have this thing that could blow up on you. Anyway, I haven't heard much about that since then. But these are the issues. How do we move large populations off of the fossil fuel regime and into the renewables?
Right. Okay, so perhaps just one last question, and before you also referred to energy transitions in human history, and last September I had on the show Dr. David Christian, and we talked about big history, and perhaps I would like here to try to connect big history with environmental history, because at a certain point we referred to the possibility of using energy or energy density as a common unit in big history, from physics to perhaps anthropology and human history and things like that. So do you think that with these energy transitions that we've been experiencing throughout our history, that perhaps that would be possible? I mean, to characterize perhaps human history or human evolution with energy as a common unit, let's say.
Yeah. I'm gonna just scan my bookshelf for 1 second. Here's the book. Let me put a plug in for Timothy Linton and Andrew Watson. Revolutions that Made the Earth. This is a book that really captures exactly what you're after, which is to say that in deep time, there have been energy revolutions in biotic and geological systems, and we think of that energy, particularly biological, and actually, planetary systems are energy systems. And how do they go through transitions? So they actually make their last transition. They have 4 revolutions that made the Earth. The 4th one is all of humanity. It's a single energy revolution. And they have. Let me remind myself of what their other transitions are. I haven't looked at this one. But yes, I do think that this is, and the idea goes back at the oxygen revolution, the complexity revolution, and then us. I thought there were 4, but either way, we can think of these things as large-scale forces. We can also, then break down their 4th, which is humanity, and talk about the genus Homo. Shifting their exploitation of plants and animals, and particularly getting fat out of long bones of carcasses on the plain on the Serengeti, and you're feeding their brains. That is essentially one of the energy revolutions. The agricultural revolution. The rise of agriculture is an energy revolution. The transition to metals is a huge energy transition. The whole history of the industrial use of fire is which is incredibly interesting. How did ceramics emerge, and how is ceramic firing technology translate into metallurgical systems, and how do they become more efficient? And then obviously the fossil fuel revolution. So all these are from my point of view, from our material environmental history point of view, as well as the big history point of view, energy density, energy complexity is a fundamental part of it. And it all, actually, we should give credit to where credit is due. An anthropologist named Leslie White he started this tradition back in the 1950s, wrote a series of articles that most anthropologists said, yeah, that's all very fine and good, I'm not really interested. But he really invented the idea of that human history is shaped by energy exploitation. We really have to understand energy. And so people need to go back to Leslie White, at least to give him the credit for coming up with the idea.
Mm-hmm. Okay, so Dr. Brooke, let's end the interview here. But just before we go, would you like perhaps to tell people what might be some of the best online resources if they want to get in touch with more of your work?
Whoa. I can't say that there are online resources to get. I have a web page with just me. I don't have a website that would be useful to the general public. No, I'm afraid not. So I can't really help you there. Yeah. Other than to buy a copy of my book. Here's the heavy library edition of my book, which is actually going to go. I'm just about to sign a contract to do the 2nd edition, which will. So this is published in 2014, and by 2022 will be old. So I'm starting the process in the next summer of rebuilding it and updating and rebuilding and changing arguments. And bringing it up to the present, because the present that will be 2022. Who knows where we'll be then? That's 3 or 4 years from now, right?
Right. And in that 2nd edition, will you include things that we've talked about in the interview, like, for example, a niche construction and other concepts like that? Yeah.
That's one of the ideas that popped up in our conversations about the 2nd edition. I had already been thinking about it, and one of my readers said, you need to think about niche construction. And I said, yes, you're right. That really is a central. And the other one is the entire resiliency literature. When I finished this book, the resiliency, there's a whole academic, multiple fields on that focus on the problem of resilience. And that was just beginning to emerge. And I talked about it. I kind of made a few changes here and there, but that'll be a much more of a central feature.
Okay, great. So when will the book be out exactly? Do you already know?
Oh, 5 years.
Okay, okay.
In the distant future. So it's not something that's imminent. It's just, we're in the beginning stages. Yeah.
Okay, okay. So anyway, I will be leaving links in the description box to your work and also to the book, of course, which I really loved and was the
Great.
central theme of our conversation today. So, Dr. Brooke, again, thank you a lot for taking the time to be here with us today, and it was really a pleasure to have you on the show and to talk to you. So.
Thank you for the opportunity, Ricardo. Yeah.
Hi everybody, thank you so much for watching this interview until the end. As you might have noticed, I've started this channel in February 2018 and have been putting out regular interviews with academics from a variety of fields. So just to keep the channel sustainable, I would like to ask you to please visit my Patreon page and to consider making a pledge there. If you don't like Patreon, you can also do it via PayPal and Subscribestar. Yeah, all of the links will be in the description box. Otherwise, and if you like what I'm doing, please share it, leave a like and hit the subscription button. I would also like to give a huge thank you to my Patreons and PayPal supporters: Karen Litske, Anne Blanchett, Perel Galarson, Lau Guerrero, Chantel Gelina, Jim Frank, Francis Ford, Hans Frederick Sunda, Brian Rivera, Lucas Stafiniak, Sergio Condreanu, Jana Enninen, and my first producer, Izar Weber. Thank you for all.